Hello everyone, welcome to my channel. This is Vijay Lakshmi. Today we are going to discuss about the module 2 AIML. That is, big companies such as Facebook, Twitter and YouTube generate enormous amount of data, and they release the data every year. The data what it is being released by them, it gets doubled every year. So we have enormous amount of data available. And next is the cost of the reduced storage. Second reason is the hardware cost has also dropped. Therefore, it is become easier to capture, store and distribute the data easily. And also we have the more complex algorithms. So with the help of these algorithms, the data can be processed for machine learning. So these are the three reasons why machine learning has become more popular. When we try to arrange this data in the form of a knowledge pyramid, we always the data is always arranged at the bottommost. Data is nothing but it can be any numbers or text that can be processed. Like if I say 15 or 20, Sita, something like that, the data is nothing but it is a raw fact. When the data is being processed, when the data has some meaning, it becomes a information. So if I say that Ramu has scored 20 marks, so it is some information. Simply if I take Ramu or 20, it doesn't have any meaning. So when the data is being processed, when the data is being added some meaning, it becomes the information. The information what we have gathered, since we have enormous amount of data released by the Facebook or Twitter or any organizations, so here the data what we have collected, when we don't need much data, the data has to be reduced. Condensed information is nothing but the information what you have gathered, it has to be reduced, it should be condensed. So that is called as a knowledge information. So once you have the information and the knowledge, you can apply the intelligence to take some decisions for decision making. So here big organizations makes use of this information to take some decisions to solve some of the problems in their organization. So this intelligence is applied, that is applied knowledge is nothing but we call it as the intelligence here. So here the last one is the wisdom. So wisdom means here by mind. It means the objective of knowledge pyramid is wisdom that represents the maturity of mind. Like this maturity of mind is exhibited only by the humans. Now what we want to do is we want the machines to think like humans and take the decisions. But the machines can't think like humans, but we have to do some programming such that to solve some of the problems, like expert systems has to take decisions. So that is now how we have to make the computers intelligent. So this is what the need for machine learning is. So we have enormous amount of data available. We have to process the data and condense that information and make the intelligent system to learn and think like a human. So that this can be used by many of the business organizations to solve some of the problems, like whether to introduce new products or improve the business process in taking some of the decisions in decision support systems and the expert systems. So actually we discussed what is machine learning. Machine learning is a field of study that gives the computers to learn without being explicitly programmed. So here humans, how do they take the decisions? So the aim is to humans take decisions based on the past experience. But the computers make models based on the extracted patterns and then use these filled models for prediction and to take the decisions. So here the computers learn from the data stored in the database, and we have to design some models to make the computers to learn. So this is how the learning system for machine learning here. Now, how do the computers learn? We have to develop some models. So here a model can be any of the following, like it can be some mathematical equations, or you can use some relational diagrams like graphs or trees to make the models to understand, or we can make use of logical if-else rules like what we use in the expert systems to train the model, and we can make use of groupings called as clusters. So here this learning program will summarize the raw data into a model. So here model can be any of this form. We can use any of these things like what we have discussed here to design a model. So it can be a formula, procedure, or it can be a representation that can generate some data decisions. So here a model is a function from y is equal to f of x. Model is a function from y is equal to f of x. Here f is a learning function that maps the input x to y. So here f is the learning function that maps the input x to the output y. So here this is called as a dependent variable. Y is a dependent on this input variable x. So we have to design some models like this. Now another pioneer of machine learning, Tom Michael, he defined machine learning as a computer program is set to learn from experience. That is, it is set to learn from experience E with respect to task T and some performance P if its performance on T measured by P improves with experience. So here he said that every computer has to learn from experience by performing some task T, and we measure the performance of P through its experience. So how it is performing the task based on that experience it has gained. So we are going to measure the performance of the machine. So here performance of the model will be measured. For example, if I take a checkers game here, so here the input what we give for this checker program, the task to be performed is to arrange the coins in the checkers board. So we give the coins and the checkers board. So it has to perform means it has to play the game, and while playing it has to win some. How do we measure the performance? The performance can be measured based on how many matches it is winning or it has lost. So here if it is winning more matches, then we say that the performance is good. Otherwise we say that the performance is bad. So like that, if you take the email classification, spam email classification, so it has to classify which is the spam mail and which is the correct email. So here if it is from spam, if it is able to perform correctly classify the spam mails and the emails, then we say that it is performing well. Otherwise that performance is not good. So here according to Tom Michael, performance of a computer is set to improve by learning experience. So it is learning through its experience with respect to some task, and it has to perform well. So that is what any model we are going to accept, whether it is based on its performance. Example, a handwriting recognition learning system. So the task T here is to recognizing and classifying handwritten words within the images. Now how do we measure the performance P? Percent of words correctly classified. So given a handwritten set of words, the model has to identify the words correctly. If it is able to identify the words correctly, then the training experience E gained is a database of handwritten words with given classifications. So it has to perform, it has to identify the words given a set of patterns in a image. So if it is able to do that, then we say that the model is performing well. Otherwise the model is not performing. So here this is one example. Next we'll discuss what is the relationship between ML, AI and DL. So DL is nothing but deep learning. So here the aim of the artificial intelligence is to design a or to develop an intelligent agent. Here the intelligent agent can be anything. It can be a robot or a human, or it can be any autonomous systems. So the here it mainly is we concentrate to develop an intelligent system which behaves like a human beings. And so here next, what is this machine learning? Machine learning is nothing but it is a subfield of AI itself. So here machine learning mainly deals with patterns for prediction. It mainly deals with how to learn the patterns and how it has to predict. And deep learning is nothing but deep learning is again a sub-branch of machine learning itself. Deep learning is a sub-branch of machine learning itself. Here the models are constructed using the neural technology, neural networks. The model is constructed using neural networks. Neural network. Here it is based on the neuron model. It is also based on the neuron model, and many neurons form a network connected with the activation functions that trigger further neurons to perform some of the tasks. So it's nothing but deep learning is also a part of artificial intelligence itself. So all these three are correlated. And whether I take the sub-branch DL or the ML, everything falls under AI. So the main aim of the AI is to develop some intelligent agents, so that intelligent agents should behave like a human to solve some of the complicated tasks or the problems, and they should help in taking some decisions for the organizations to improve their business. So that is a main task of the machine learning. And here machine learning and data science, we say that here data science is an umbrella term covering from data collection to data analysis. So what is the relationship between machine learning with other major fields? Machine learning also deals with data mining, pattern recognition, big data and data analytics. So here since big data means here data science concerns about collection of data. It's a field of data science that deals with data's following characteristics, like it deals with the volume, variety and velocity of the data. So huge volume of data gets released by companies like Facebook, Twitter and YouTube. So big data has to handle that data, and data is available in variety of forms like images, videos and different formats. So big data has to deal with the different formats of data, and the speed at which the data is released is also more. So here that is the reason this branch of study, this branch of is very useful for the machine learning, since it can gather enormous amount of data from the big data itself. And data mining makes use of tremendous algorithms like supervised, unsupervised and reinforcement learning. So this data mining algorithms itself is used in machine learning to take to develop some of the models. So it also deals with the data mining. And pattern recognition, it uses machine learning algorithms to extract the features for pattern analysis. This branch of study, pattern recognition, also makes use of machine learning for pattern classification and recognition, and it is also used in specific applications. Even machine learning also makes use of this pattern recognition. And coming for data analytics, it is also another branch of data science. it aims to extract useful knowledge from the crude data. There are different types of analytics like predictive analytics and predictive, which is used for making predictions, and machine learning is closely related to this analytics and shares almost all the algorithms. So here analytics plays a major role in the machine learning. So what do we say here is data science is nothing but it includes all these subfields to make some of the models. So that's what this subjects, each one is interrelated with the other one to develop some of the models. So like how we discussed, big data is nothing but here data science concerns about collection of data. Big data mainly deals with three characteristics, that is volume, variety and velocity. So huge amount of data is generated by companies, and data is available in different forms like images, videos and different formats, and velocity refers to the speed at which the data is generated and processed. Coming for data mining, so here data mining and data science, how actually data mining is used in data science. So here data mining's original genesis is from the business. It's mainly for the business. Like while mining the earth, one gets precious resources. It is often believed that unearthing of the data produces the hidden information that otherwise would have eluded the attention of the management. So nowadays, consider data mining and machine learning are same. Like how we dig the earth deeper to get the minerals what has been stored. Here also the same way, we dig deeper, we mine inside to know the data better, to extract the hidden patterns that are present in the data, so which can be used for prediction, which is used by the machine learning to make some of the predictions. So like how in mining they dig the hole deeper to extract the ores and minerals, here also we dig deeper the data. We dig deeper the data to extract the hidden patterns, and which is used to make some of the predictions. Now data analytics, like how we discussed previously, it is also a branch of data science. It aims to extract useful knowledge from the crude data. There are different types of analytics. Predictive data analytics, which is used to making predictions, and machine learning is also closely related to this data analytics, and it also shares almost all the algorithms what we use in data mining. And coming for pattern recognition, it is also an engineering field. It uses machine learning algorithms to extract the features of pattern analysis and pattern classification. So one can view this pattern recognition as a specific application of machine learning. So this is the main thing here. Based on the patterns only, the machine can learn. So like if I use supervised classification or unsupervised classification, to make the model to learn, I have to make use of some of the patterns and train the model. And I should make that model to learn first, and then I have to make that model to predict some results based on the patterns what I am going to give as an input. Now statistics, again it is a main branch of mathematics. So this statistics is mainly used in machine learning. Everywhere we use the statistics, but the difference between statistics and ML is that statistical methods look for regularity in data called patterns, and statistics sets hypotheses and performs experiments to verify and validate the hypothesis in order to find relationships among data. So here statistics are mainly used in machine learning to design different sets of hypotheses. Hypothesis means here how we are going to make some assumptions to make a null hypothesis or alternative hypothesis for the model to make some of the decisions. So that hypothesis is mainly designed with the help of statistics in machine learning. So statistics also has a major role in machine learning. So whether I want to classify my model under classification or regression, to take some of the decisions based on statistics only, with the help of hypothesis setting, we take some decisions. So statistics plays a major role in machine learning. So here we are discussing about machine learning types. Machine learning is classified into 4 types as supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. Supervised learning in turn classified as classification and regression, and unsupervised learning can be classified as cluster analysis, association mining, and dimension prediction. Now, what actually is a supervised learning? In machine learning, we have something called as labeled data and unlabeled data. Labeled data and unlabeled data. So we know data is a raw fact. So data can be represented in the form of tables, and each data, these tables has some name. The table has a set of columns or the attributes. Like if I take an employee details, so I have attributes like employee name, employee salary, employee date of birth, like this. So each of the column has a label that is called as a name. Attribute name, what we are giving itself, is called as a name here. And each row of the table also represents the data point. So here that is the label. What is the name we are given for each of the attribute is the label. With this label data only, we make the model to learn and predict something. So here, if you are using the labels for your data set to make the model to learn, means with the help of label data it will start learning, means it is called as a supervised learning. So here this supervised learning makes use of a labeled data set. So like we say that there is a teacher or a supervisor component to make the learning system to learn. So this supervised learning can be classified into 2 types, classification algorithms, and we have something called as a regression algorithms. So here it makes use of a teacher, a supervisor. This labeled data set is labeled data acts as a supervisor to make the algorithms to learn. Now coming for unsupervised learning, it makes use of a unlabeled data set. It doesn't have any labeled data. It has to learn by itself through experience. So here it is self-learning, we say, in case of unsupervised learning. So here we have different kinds of algorithms which comes are cluster analysis, association mining, and dimensionality reduction algorithms. So anyhow, we are going to discuss about this all unsupervised learning algorithms in the next coming modules, like module 3 and 4. So supervised learning makes use of a teacher to learn, whereas unsupervised learning learns by itself. It doesn't need any labeled data set to make the predictions. And we have third type, semi-supervised learning. Here it is a combination of both labeled and unlabeled data set to make the model to learn. Both combinations of labeled and unlabeled data set can be used. And again, reinforcement learning. Here in reinforcement learning, the model the agent has to interact with the environment, and when it interacts with the environment, it gets some rewards. Based on the reward it has received, it can be a positive reward or it can be a negative reward. So based on that experience what it has gained, it has to store the data and it has to learn by itself. So here we can consider the agent to be as a robot, or it can be any independent program. Here like how we humans see, hear and see and pursue to the environment and learn to take some actions based on our knowledge what we see and hear. The same way the machine learning has to interact with the environment and then it has to pursue, that is it based on the reward what it has received, it has to take some of the decisions. So again here it is also learning by itself without any data. So like this we classify the machine learning algorithms into 4 types. So in the next coming sessions in deep we are going to discuss what actually is supervised and unsupervised. Labeled data set for predictions. So neural networks makes use of the images like this as well as the label. So the input can be any images, like we have taken the dog and cat images for prediction, and you can along with the labels. So both can be used by the deep neural networks, whereas supervised machine learning makes use of only the labeled data for making the decisions. Coming for unlabeled data, data that is not associated with labels are called as what? Unlabeled data. Now here this unlabeled data is mainly used by unsupervised learning algorithms. So based on the patterns, it has to classify whether this is a dog or a cat. Now coming for the supervised classification algorithm, in supervised classification already we have discussed that we need a supervisor or a teacher to make the model to learn. So that is why the name is given as a supervised. Supervised machine learning algorithm makes use of labeled data. Okay, we have the data set can be classified into 2 types, like the data in the data set can be classified as training data and testing data. So here we train the model, we have 2, training and testing. So we train the model by using 80% of our data set and 20% we keep for testing purpose. Now we have to train the model by using some of the classification algorithms. So you can make use of some classification algorithms like decision tree, cluster based algorithms, etc. And you can train the model with the help of labels. So here the classification model, the learning model has been designed with the help of label data and the classification algorithms. The model is designed and you are testing your sample by giving the testing sample. We have some data, so that data is given as an input and it should predict that the given based on the input what you are giving and based on what it has learned. Okay, through training period it has learned the patterns of the data, what is a dog and what is a cat. Based on that, now if I give my test data as an input, the model should be able to classify it and label. Here we get the result as cat. So here the input what we are giving is a cat, our test data is cat image. So now the model has to label it as a cat. So this is a classification algorithm. So here we are going to train the model. 80% of the samples are used here to train the model in supervised learning. So once it learns those patterns, we are testing the model now. Now the model, when I give some input, it should be able to properly classify. It should make the prediction whether this is a cat or a dog. So this is what our supervised learning is. So in the examinations and all, you cannot draw the symbols like this. Instead of that, you can make use of some symbols like triangle symbols and circle symbols like this. And when this is my I may make use of any of my classification algorithms, and well, I have designed a model, and if I give an example like triangle here, okay, now this is my test data. The model should be give me the result. The label is triangle. It should display my label is triangle. So that is what my supervised learning is. So at this point of time, we are not worrying about what kind of algorithms, supervised algorithms they are using and how it is being classified and all. You need not worry, because this is just a basics now. So how we are going to classify and all is the next coming chapters. We are going to discuss how the decision tree algorithms or any classification algorithms taking these samples, label data as an input, and how it is going to classify. All those are our next step. So at this point of time, just you should know what is the classification algorithm? Classification algorithm mainly makes use of labeled data set. So with some models already we have discussed in the previous slide. It can be any of the mathematical equations, or it can be any of the statistical equations, or it can be a database or a knowledge base. Anything it can be. Through that it has to learn, and it has to take some decisions. It has to learn the data, and then it should be able to predict the data. So that is what this supervised learning is. Next, what are the supervised algorithms? We have different kinds of super algorithms like decision tree, random forest, support vector missions, naive Bayes, and artificial neural network and deep learning learning networks like CNN. These are mainly used to classify the images and the label data. So each one of them will discuss in the coming slides. Now coming for supervised learning, the second type of classification is regression algorithms. So in regression, we always plot the data in the form of a straight line. So here to understand the regression model, given a set of data points, we draw a 45-degree line to understand the regression model. Y is equal to AX plus B. We consider this Y equal to AX plus B, where my X is the input variable and Y is the output variable. So the Y is dependent on this X. X is an independent variable. So here the regression model takes input X and generates a model in the form of a fitted line. This is called as a fitted line. So it always takes inputs from the X. And now here this independent variables, that is X is the independent variable here, A and B are the coefficients. So here this coefficient values is again fixed by the domain experts to take some of the decisions in solving some of the regression related problems. So whatever the data points you point here, you classify into two groups as the points above the data line or below below this fitted line, which are the data points falls under, and then based on that you might have to take some of the decisions. So this is one of the sales analysis prediction line given. What is the sales of that particular product in a day or in a week? If I plot a graph, so I have got a regression line like this, and this regression line, the function what we have used is f of x equal to a of x plus b. So this is a product sales, and again this 0.66 and 0.54 for weekly analysis is fixed by the domain experts in their business organizations. So like this you can make use of any of the function, and y equal to f of x, you can design your function for your sales and make the predictions. So clustering is a grouping process. Clustering means it's a group, we say. This clustering is an example of unsupervised learning. It aims to group the objects into two disjoint clusters. So if you see this example here, we have a group of cats and dogs. So and it is of unlabeled data. So here the cluster, it forms a cluster of two groups. One is called as cluster 1, that is group of cats, and cluster 2, group of dogs. Now the model learns by itself. Okay, it doesn't have any labeled data here. It's an unlabeled data. It has to segment it into two groups, and then it has to predict the based on the input what we have given. So here in unsupervised learning we have two types of learning, that is k-means algorithm and hierarchical algorithms. Clustering algorithms are classified into two types, and also we have something called as a dimensionality reduction algorithms. So all these are examples for unsupervised learning. Next, what is the difference between the supervised and unsupervised learning? So here in supervised learning there is a supervisor component, a teacher to make the model to learn. In unsupervised learning it is self-learning. It doesn't have any supervisor. Supervised learning makes use of a labeled data for model prediction. Here, unsupervised learning makes use of unlabeled data. So it groups based on the patterns. Based on the patterns, it may group into different clusters, and it will identify the data set, whatever you have given, to which group it belongs, and categorizes into that particular group. And supervised learning assigns categories or the labels. Okay, supervised learning has the labels already we have discussed, and it performs grouping process such as similar objects. Unsupervised learning groups similar objects as into one particular cluster. Cluster is nothing but again a group, like how we saw in the previous example. One group is cats cluster, another group is the dogs cluster. So divides into two groups and sees the model input, whatever we have given, it belongs to cluster 1 or belongs to cluster 2. So this is a major difference between the supervised and the unsupervised machine learning. Next, we have something called as semi-supervised. So here, as we know that data set consists of huge amount of data, and much of the data is unlabeled, and some data can be labeled. So here, if it is a combination of both labeled and unlabeled data, means it is also called as a pseudo label. So semi-supervised algorithms use unlabeled data by assigning a pseudo label. Then this pseudo label can be used in the data set for model predictions. Since it's a combination of labeled and unlabeled data, for unlabeled data you can give one false label, then you can start making use of the data set for predictions. So it is a combination. Semi-supervised learning, it's a combination of both labeled and unlabeled data. Suppose if you receive a sample data set in a hospital, some of the attributes for fields for some of the patients might be filled, and some of the fields may not be filled, and label might not be given there. So if the data is like that, then it is a combination of supervised, labeled and unlabeled data, where we can assign some labeling to the left out attribute names. Now the third type of learning is the reinforcement learning. Fourth type, reinforcement learning. So here we say that it mimics the human beings. Like human beings use ears and eyes to perceive the world and take some actions. Reinforcement learning allows the agent to interact with the environment to get the rewards. It means that the agent has to learn the environment by itself. Okay, and based on the rewards it is gaining, either the rewards can be a positive reward or a negative reward. So based on the reward behavior, it stores that circumstances feedback, and then to make the moves towards left or right or up or down based on the reward what it has received, it stores that information in its database. Based on that, to take any prediction or to reach the target, the agent may take some decisions by storing the feedback what it has learned, by making the moves, what is the feedback it got. Based on that, it will take the decisions to reach the target. Now the agent can be a human, or it can be an animal, robot, or it can be any independent program. So here agent has to learn by performing some task, and based on the experience it has to gained by the past, okay, by the feedback what it has received by performing that particular task, it has to store that in its knowledge base, and then it has to perform. That performance can be measured based on how the model is performing for that particular behavior. So whether it is performing good or it is performing bad. So based on that, we can take some of the decisions. So here this is it is also based on the output what it has received by making certain moves. It will store that in the knowledge base, and then it will take some decisions to reach the goal or the target. So what are the challenges faced by the machine learning? So there are some certain problems which the machine learning cannot solve As we all know that problems can be classified into two types as well-posed problems and ill-posed problems. So well-posed problems has a definite algorithms and procedure to carry out a task. But the computers cannot solve ill-posed problems. So here in ill-posed problems, the specifications are not clear. So here what to carry out, what is the task to be carried out? The input specifications what we are giving to the learning model to learn, it is not clear to the model. For example, we know that machine learning can deal with only well-posed. Assume that my input is like this. So one of the problems what the computers cannot solve, that is the ill-posed problems. Assume that my input is variable x1 and x2. They are the independent variables and my output variable is y. Now my input values are 2, 1, 3, 1, 4, 1 and so on, and again I have here 1, 1, and my output variable is 1, 2, 3 and 4. Now can a model for this test data be multiplication? If I design a model y equal to f of x, my model is y is equal to f of x. This is a model I have designed. Now what is this f of x now? Now if I take this function y is equal to x1 into x2. This is x1 into if I take x1 into x2, my function, here I have x1 is 2 and 1 is 1. So 2 into 1 is 2. And if I take 1 into 1, it is 1. My x1 is 3 and x2 is 1. 3 into 1 is 1. Similarly, if I take my function y equal to f of x as y is equal to x1 divided by x2. Suppose if I take my model like this, y is equal to x1 divided by x2. Now my x1 is 1, 1 divided by 1 is 1 only, 2 divided by 1 is also 2, 3 divided by 1 is 3. And assume that now I am taking the third function, y is equal to x1 raised to x2, x1 square, that is x1 raised to x2 I am taking. Now my x1 value is what? x1 is 1. Now x2 value is 1, 1 raised to 1 is 1. Now my x1 value is 2 here and 2 raised to 1 is 2. I am getting the same output variable 2 here, and if I take x3 raised to here, if I take my x1 value as 3 and x1 value as 1, 3 raised to 1 is also 3. If you see all these three functions, if I take x1 into x2 or x1 divided by x2 or x1 raised to x2, the output remains the same. All the three functions, all the three specifications are giving the output variable as 1, 2, 3 and 4. But the model cannot understand this, that I have used which particular function to get this particular output. So here to solve this problem, one needs more examples to check the model. Okay, to check this model we need more examples. But if you take our puzzles and games, they do not have a sufficient specifications. Since our puzzles and games don't have a sufficient specifications, they are called as a ill-posed problem. Because my model will work for any one particular formula only. Either it will work for y equal to x1 raised to x2 or y equal to x1 into x2. But it doesn't know that both of them will yield the same output itself. Because we humans can think like that. But the model doesn't know whichever equation I have used here, the functional equation, according to that only it will work. So if I rewrite my equation, if I give, it will not make a proper decisions. So that is called as a ill-posed problems. But we humans can analyze that. Anyhow, if I use all the three different ways, I'll get the same result like this. So that is the difference between the humans. Humans can think and take the decisions, but machines will not think according to the equations model you have, how you have designed. According to that only it will work. So that is one of the challenge of a machine learning, how to make the model to think like us and take the decision. So that is one of the challenge, because it can solve only the well-posed problems. How you have designed the mathematical model, accordingly only it will work. It cannot say like how we justify if you do like this, or if you take the division or multiplication, or for this one square of this equation, however I rewrite, I'll get the same target output. And next second challenge faced by machine learning is the huge data. So here we know that availability of the data is again a challenge here, and enormous business organizations are releasing enormous amount of data every day, and this data what has been released by business organizations is inconsistent data. It is not consistent. Some of the data might be of missing values, some values might be misinterpreted values. So like that, the data what we are getting, it is not in a proper format, and it is also an incorrect data. Okay, so that is one of the problem, and huge computation power is also needed. So here, since with availability of big data, the computational resources requirement is also increased. So we say that systems with GPUs or even tensor processing units are required to execute some of the machine learning algorithms. So more capacity, because since the learning has become more complex and the time complexity is also increased, and we need more computational power to solve such kind of problems. So since we need more computational power to solve, so here computation, huge computation power, that is also one of the challenge. How many GPUs or TensorFlow units we need in order to process that particular data. And the third point is the complexity of algorithms. Complexity here means selection of algorithms. Since we have enormous amount of algorithms in data mining as well as in machine learning, here the comparison of algorithms have become necessary for the machine learning and for the data science to choose which is the best algorithm among all the available algorithms, which particular algorithm we have to choose for our models so that the predictions should be good and accurate. So that is one of the problems, since the more algorithms are available. And the fifth is the bias and the variance. So we'll know that this variance is nothing but it's an error of the model. So the error might lead to a problem called as a bias or the variance we say. So here, if the model that fits the training data correctly, but if it fails for the test data means, then we call it as the overfitting. This bias and variance may lead to two kinds of problems called as overfitting and underfitting. So here for training data, it is predicting, it is not predicting properly, but for test data, it might be predicting properly. So that is nothing but we call it as overfitting. And some of the models will predict properly for the training samples, and for testing samples it may not predict properly. It may give some erroneous results. So that error or precision what it has been displayed is called as a underfitting. So some leads to overfitting problems and some leads to underfitting problems. So these are some of the challenges faced by the machine learning. Some training samples might work for testing data. Some of the samples may work better for the training data, which leads to an underfitting and overfitting situation, which is called as the bias and the variance. Next, coming for machine learning or data mining process, it is again an important question for the examination point of view. So here, this model, the process of machine learning involves 6 different steps. First is the understand the business, understand the data, and data pre-processing, modeling, model evaluation, and model deployment. So any machine learning model should undergo all these steps. So any model what you are designing, first you should understand the business. For what particular purpose you are designing the model. So here you have to understand the objectives and the requirements of the business organization. So here you have to understand what is your problem statement. What should be your problem statement to solve what kind of problems you are designing this particular model, so that the business has to be improved. Okay, to take better decisions, to improve the sales of the product, etc. Okay, so what is your problem statement? Understand the business. Then, based on the formulation of the problem statement, okay, you have to, based on the formulation of your problem statement, you have to understand what data you need to solve your problem. So here this step, understand the data, is nothing but data collection. To collect the data to solve the problem. So what data is needed here? Then you have to study the characteristics of the data, and you have to formulate a hypothesis to you have to design a hypothesis to solve your problem. Okay, to solve your problem statement, you have to form a hypothesis, understand the data, you have to clean the data, you have to prepare the data, okay, to reach the objective of your problem. Next is data pre-processing. So this step involves cleaning of the data. So now you have analyzed what data you need for your problem. Next, you have to clean your data, preparing the data for the data mining process. Cleaning means if any missing values are there in your data samples. So whatever you're taking, you have used some missed values, or different data types has been used in your product, in your data. So you have to remove that. Cleaning missing values or any causes problems during testing and training phases means that data you have to properly modify the data. Okay, data pre-processing, cleansing of data is nothing but data pre-processing, we say. So any irrelevant data is there, or any missing values are there in your data, what you have chosen, just you have to remove all those data. Okay, you have to handle that data properly. Once the data cleaning is over, mishandling of the data is over, then you have to design a model. So this step plays a role in the application of data mining algorithms for the data to obtain a model or a pattern. So you have to design which particular algorithms you're going to use to design your model. So how you're going to design your model, what kind of learning model, whether it is a supervised or unsupervised or semi-supervised learning model you're going to design. So what is the model pattern will be, you have to decide here what data mining algorithms I'm going to use. Next is, once you have used data, you have decided with your algorithm and the data set is ready for you, then you start evaluating your model. So you are implementing your model. Next, model evaluation. So this step involves the evaluation of your data mining results using the statistic analysis and the visualization methods. So the performance of the classifier is determined by evaluating the accuracy of the classifier, whether your model is predicting according to the target what you have set or not, how your test data, whether the test data is being correctly predicted as like the trained data, what is the bias and the variance involved there. So that you have to, based on these parameters, you have to evaluate your model. Okay, so here you are measuring the performance of your classifier, how you have designed performance of your model. Also here it can be a classifier or it can be a cluster based analysis. Whatever it is, you have to evaluate according to the target set by you, your expected result and the predicted result. Both should be matching. Okay, it should be reach at least 90% of your expected result. Your predicted model should be able to predict at least 90% of your expected model. Okay, next, once it is successful, then we deploy that model. The last step is the model deployment. So here, deployment of results of the data mining algorithm to improve the existing process or for a new situation. So here you are going to deploy a model. If your model is predicting accurately, so you may try to replace the existing one, or it may give rise to a new models from this one, so that the sales of this business can be improved. That is a model prediction example what we have taken. So this is the machine learning process every time. So it should understand the business and it should understand the data. If the data what you have collected, if it is not matching your business, again you have to reformulate your problem. You have to reformulate your problem, and again you have to collect the data for that. These steps, data understand, data pre-processing, all are interlinked with each other. You can for data pre-processing, you are removing any unrelevant data or any mismatching of data is there, or duplicate data are there. You have to clean that particular data, and then you are coming up with a model. So model in turn, while it is performing, we're implementing the model, you may need some of the cleaning of the data. Again, you can do at this stage also. You can pre-process your data for a proper prediction. Once the model is being ready, it is evaluated. The results are compared with your expected results, that is the target output. If it is performing well, then we deploy that model. We put that model into use. So this is the process of machine learning. So here we are going to discuss about machine learning and its applications. Machine learning technologies are used widely now in different domains. So one such application of machine learning is in sentiment analysis. So here this is an application of natural language processing where the words of a document are converted to sentiments like happy, sad or angry, which are captured by emotions effectively. So here sentiment analysis can be done with the help of emojis for movie reviews or product reviews, or 5 stars or 1 star can be automatically attached using our sentiment analysis programs. So here if you take our Facebook or Twitter or Instagram, we try to express our emotions by using some of the emoji pictures or by using some of the words like happy, sad or angry. So whatever we are using, those applications are also based on sentiment analysis. Next, we have something called as a recommendation systems. So here these are systems, these are called as a personalized purchases systems. Wherever it is possible, we make use of this recommendation systems. All the Amazon or Flipkart to market their products, they make use of these recommendation systems. Based on your previous purchase, these models can suggest you some of the existing new products based on our previous search of movies or the text or the products, whatever we have searched in that particular recommendation systems. So it is also one of the application of ML. Next, we are more familiar with the voice assistants like Google Assistants or Amazon Alexa or Apple Siri and Microsoft Cortana. So all these are voice-based assistants. They take speech commands and perform the task. So the chatbots are the examples of this. So chatbots are used everywhere. They are used in the PhonePe or Google Pay, or in any of your, we can see in any of our mobiles or customer call centers, your IBRS, whatever we are using, everything is based on voice assistants. And all these are also applications of ML. And every day what we use is our Google Maps. So these are also technologies based on ML. So Ola, Uber, etc. all make use of this Google Maps to locate some of the destinations, to navigate and find the shortest path so that the time can be reduced. So this is also an application of machine learning. So not only this, machine learning is mainly used in many of the domains, like it is used in business for predicting the bank corruptancy, and it is used in banking to identify the loan defaulters or any credit card fault detection. If you want to find frauds, we make use of this in banking system. And for any image processing, that is to identify any of the theft in the theft, we can make use of this image processing. And audio or voice, mainly used in Alexa and some of the Microsoft applications. Voice assistants also makes use of this for supporting the customers to convert the speech to text or text to speech can be done, and it is also used in telecommunication to identify some of the bogus calls or fraudulent calls. And ML is used in marketing for improve their sales, for taking business related decisions, for analysis, stock market analysis, etc. And also machine learning is used in games to design many games like chess games or checker games, etc. We can make use of this ML. And for Google translations, natural language translators are used to translate from one language to another language, or for summarizing of any text, or to identify the emotions or sentiments of a customer with the help of natural language translators also we can use, which is an application of ML. And ML is also finding its application in web analysis and services, that is identification of access patterns, and to detect any emails as spam or not, or any personalized viruses introduced into the network can be identified with the help of ML. And ML also plays a major role in medicine, in prediction of diseases like cancer or diabetes. And also there are been a different chatbots has been designed by the IBM to interact with the patients and collect his feedback, and based on that, using the pattern history, it can make some of the predictions for that particular patient. And it is used in multimedia and security for face recognition and identification of any biometric related task has to be done. It can be used, which involves multimedia retrieval of different kinds of applications, and is used in scientific domain for discovering of new galaxies and identification of groups of houses based on the house type or geographical locations, identification of earthquakes, epicenters, and identification of similar land use. It can be used, ML can be used in certain of these applications. So here we say that in our to identify any new galaxies in the space, or to identify groups of houses located in different geographical locations, or to predict the earthquakes or any landscapes happening, we can make use of this machine learning. So all these are some of the applications of machine learning. Machine learning technologies are widely used now in different domains. So it is an umbrella for different types of domains. So we'll see the collection of data. Understand the different kinds of data. We'll discuss in the second chapter. I hope you have understood this first chapter in ML. This is just a basics. Okay, so we are not gone anything in depth here, just we understood what actually is a machine learning, what is the need of machine learning, and what is the process of machine learning and its applications. So in the next coming videos, we're going to see what are the different kinds of algorithms and what kind of data has to be gathered. Please subscribe to my channel. If you are not subscribed, your subscription is more important to me. Thank you.